Welcome back, my dear students. The problems part on the chapter friction. Okay, we have learned the theory chapters, means theory topics, in the last two classes. So this is my third class on this friction chapter. Okay, we will see the problems. So here in this problems part, okay, we have four types of question on the problems part. Okay, what are those four types? So problems on horizontal plane. Okay, problem will be on horizontal plane. How? A body is given, a horizontal plane is given. Okay, we have to find either the pulling force P or the resisting force F, or we have to find the properties such as this coefficient of friction. Okay, like that some problems will be there. Next, problems on block, same block placed on the inclined plane. When this horizontal plane is inclined, okay, is inclined to the horizontal with some angle, what will be the resisting force or the friction, what will be the P, okay, which force are acting, so etc etc we have to find. Another problems is on the wedge friction. So wedge, when I'll come to this topic, I'll talk about this wedge friction, and also the problems on ladder friction. So we have four types of problem. So first one is on horizontal plane, second is on inclined plane, third problem on wedges, fourth problem on ladder friction. Okay, I'll solve some of the important problems on every topic. Okay, today let us start the type first, that is the problems on the horizontal plane. Okay, here the question is given. See, a body weight of 1000 Newton is placed on a rough horizontal plane. Determine the coefficient of friction due to the force 600 Newton in horizontal direction, which just causes the body to slide. Okay, what they have given, a body of weight 1000 Newton is placed on a rough horizontal plane. So a plane is there, and on that a body is there. So the plane is rough, they are already saying it is rough, so friction will be there. So determine the coefficient of friction. We have to determine what we have to determine the coefficient of friction. Okay, due to the force 600 Newton. So they have given P, that is 600 Newton, just in 600 Newton in horizontal direction. Okay, in this horizontal direction just causes body to slide. Okay, so this is the force P. So weight they have given as 1000 Newton. So just note down the given. So I'll take the weight which acts at the center of the body, that is 1000 Newton. So this is 1000 they have given, this is 600 Newton they have given. Now we have to find out the coefficient of friction. So in the theory part, what we have learned, the coefficient of friction is mu is equal to F by R. So we know the formula, this one. Okay, with this we will continue the problem. So P is the force, W is the weight. So due to this weight W act ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಇನ್ನೊಂದು ಫೋರ್ಸ್, ನ್ಯೂಟನ್ಸ್ ಥರ್ಡ್ ಲಾ, ಫಾರ್ ಎವ್ರಿ ಆಕ್ಷನ್ ದರ್ ಇಸ್ ಅನ್ ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್ ರಿಯಾಕ್ಷನ್. ಓಕೆ, ಈ ವೇಟ್ W ಫೋರ್ಸ್ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇನ್ನೊಂದು ರಿಯಾಕ್ಷನ್ ಫೋರ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಡ್ಯೂ ಟು ದ ಫೋರ್ಸ್ W ದೇರ್ ವಿಲ್ ಬಿ ಅನದರ್ ಫೋರ್ಸ್ R that is normal to the horizontal surfaces. And here see the P force is in this direction, so obviously next, therefore the friction force will be in this direction. So F is in this opposite direction, because the motion of the trend is this. Motion of the trend ಅಂದ್ರೇನು, ಈ P ಫೋರ್ಸ್ ಇಂದ ಬಾಡಿನ ಪುಲ್ ಮಾಡಿದರೆ ಈ ಬಾಡಿ ಈ ಕಡೆ ಹೋಗುತ್ತೆ ಅಂತ ಅರ್ಥ. ಸೊ ಮೋಷನ್ ಆಫ್ ಟ್ರೆಂಡ್. ಸೊ ಮೋಷನ್ ಟ್ರೆಂಡ್ ಅಂದರೆ ಬಾಡಿ ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ ಅನ್ನೋದು. ಸೊ ಬಾಡಿ ಈ ಕಡೆ ಮೂವ್ ಆದರೆ ಫ್ರಿಕ್ಷನ್ ಫೋರ್ಸು ಈ ಕಡೆ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ, ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫೋರ್ಸ್ ಆಫ್ P. ಸೊ ಇಲ್ಲಿ ನಮಗೇನು ಗೊತ್ತಿದೆ, ಮ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು F by R ಇದೆ. ಸೊ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ರಿಟರ್ನ್, F ಬೇಕು ನನಗೆ. ಸೊ ಮ್ಯೂ ಇಂಟು R. ಕ್ಯಾನ್ ಐ ರೈಟ್? Okay, this formula we know from the theory part, that is coefficient of friction is equal to it's the ratio of limiting friction to the normal reaction. So I'll take this as equation number 1. F is equal to mu r. Now considering the free body diagram, of block. So I'll consider the free body diagram of the block. So what it happens, so I'll take this block, okay, then this weight is acting downwards, right? So I will take it as downwards. So W, which is equal to 1000 Newton, this R is acting upwards. So with this point I will take is upward R, okay. Another load is acting, that is P. So P is 600 Newton, okay, and force is opposite to the P. I will take here force. So now what I will do, I will introduce the axis system, x-axis and y-axis. So we know the angles, okay. Now so okay, leave out the angles, just you consider the equilibrium of force concept, that is sigma h equal to 0, summation of all the horizontal forces equal to 0, summation of all the vertical forces equal to 0. So what is the condition for this? Sigma summation of all the horizontal forces equal to 0, taking left to right as positive. For this, summation of all the vertical forces equal to 0, taking upward as positive. So first one I will take, that is sigma h equal to 0, taking left to right as positive. So what are the horizontal forces? We have P, okay. So P, this F is left to right, so I will take it, it becomes minus P minus F. Then which are the horizontal, ಮತ್ತೆ ಯಾವ್ದಾದ್ರು force ಇದೆ horizontal? ಯಾವುದು ಇಲ್ಲ, no forces remain in horizontal, so is equal to 0, which implies that P is 600. We know 600 minus F is equal to 0. What it implies, that F is equal to 600 Newton, okay. F is equal to 600 Newton. Now I'll take another condition, that is summation of vertical force equal to 0, taking upward as positive. So what is the vertical force? So W is the vertical force and R is the vertical force. So I'll get R as positive because upward, minus W is equal to 0, okay. Now I know the value of W. R minus 1000 is equal to 0, which implies R is equal to 1000 Newton. So we got the frictional force F 600 Newton and the reaction R is 1000 Newton, okay. What we want here? We want mu, okay. So what is the formula? F by R. Just substitute mu is equal to 600 by 1000. So mu is equal to 0.6. So it is unitless, okay. Sorry. So mu is equal to 0.6. So friction is also force, R is also force, so Newton gets cancelled and it will be a unitless. So the value of mu is 0.6, okay. So this is how we solve the problem. It was the first problem. Now we'll go to the second problem. I'll write down the question, okay. Second problem. So second question is, a body weighing 100 Newton is placed on the rough horizontal plane pulled by a force of 30 Newton, inclined at 15 degree with the horizontal. Find coefficient of friction. Now onwards I will use the short forms, okay. What is they are telling? A body weighing 100 Newton, okay. This is the body weighing 100 Newton is placed on a rough horizontal plane pulled with a force of 30 Newton. It is pulled with a force of 30 Newton, inclined at 15 degree. So I'll take one parallel force, okay. So this P force, P is 30 Newton and it is inclined at 15 degree with horizontal. Find mu. Okay, so this is the diagram. In the next page I'll write directly the free body diagram. So due to this P force, okay, which is inclined at 15 degree and this is the weight 100, we'll have a reaction R. Okay, then we'll have a frictional force opposite to the force in P. Okay, I'll write the free body diagram in the next page. I'll write the free body diagram. So a body is there. Okay, so weight was 100 Newton. So due to this weight, R is created, that is normal reaction. So P is like this, that is 30 Newton but inclined at 15 degree. Now friction force will be this, opposite to the direction. I'll introduce the axis, x axis and y axis. Okay, so we know mu is equal to F by R. Okay, so we will apply the same concept, that is sigma h equal to 0, taking left to right as positive. What we will get, see here, so here the P is inclined. So any inclined forces if we come across in this chapter, we have to resolve it. We have to resolve it as horizontal and also vertical. So P is equal to 30 Newton sorry, and it is at 15 degree, right? So what it happens, so this one horizontal force, this is vertical force. So P cos 15 degree, P sin 15 degree. So this is P cos 15 degree as the horizontal force. Okay, so this vertical force will be P sin 15 degree. Now apply. So this P is left to right. Okay, take it as positive. What will be the horizontal component? P cos 15 degree, then minus F is equal to 0. So we know the P value, 30 cos 15 degree minus F we have to find is equal to 0. Therefore F is equal to, I'll just calculate, so that is 30 cos 15, 28.97 Newton will be the force. Now sigma vertical force equal to summation of all the vertical forces equal to 0, taking upward as positive. So what are the upward forces? So here R is the upward forces. Okay, and also the upward forces came by this P, that is upward component, P sin 15 degree, and also another force, vertical force, that is 100 Newton. So what will happen, I'll take first positive one, R. Okay, this R plus P sin 15 degree, then 100 Newton which is in downward direction, minus 100 Newton is equal to 0. Now R plus, we know the P value. What is the P value? 30 Newton. So 30 sin 15 degree, 30 sin 15 degree is 7.76 minus 100 is equal to 0. Therefore the value of R is equal to, so 100 will be 7.6, 100 minus 7.76, 92.24 Newton. So this is the value of the reaction R. Okay, so what we need to find, we need to find mu, that is F by R, that is nothing but 28.97 divided by 92.24 which will fetch us mu is equal to 28.97 divided by 92.24, 0.314. This is the value of mu. So this is how we solve the problem. Okay, so two problems were easy and they were the basic problem. Now I'll show another problem which is some more concept is added in that problem. That's it. It will be easy only. Okay, I'll write down the question and I'll let you know. Third problem. A block of weight 5 kN rests on a rough horizontal surface and coefficient of friction is 0.4. Show that magnitude of force required to pull is less than the magnitude of push if the angle made by both the forces, that is push and pull, is 30 degree. Okay, what is in this problem, what they are saying, a block of weight 5 kN. So this is a block of weight 5 kN rests on a horizontal surface. Okay, it will be rested on a horizontal surface, and the coefficient of friction, they are giving the mu value. What is the given? So mu is given, that is 0.4. Show that the magnitude of force required to pull. Okay, so the magnitude of force required to pull is less than the magnitude of push. Okay, so what they are telling is if the angle made by the both is 30 degree. Okay, so this block is there. Okay, this block is on rest on the horizontal surface. Okay, so this block is pushed and also it is pulled. So we have here two cases. One is when the block is pushed and one is when the block is pulled, and they are pulled with an force value of 30 degree. If it is pushed, it's also 30 degree made by the, so angle is 30 degree. Okay, for both the angle is 30 degree, and we have to find the magnitude also. We don't know the value of P with which magnitude it is being pushed, we don't know, so we have to find P also. Okay, and what we know also weight 5 kN weight we know. Okay, ನಮಗೆ P ಕಂಡುಹಿಡಿಯಬೇಕಿಲ್ಲಿ. ವೇಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಜೊತೆಗೆ ಒಂದು ಬ್ಲಾಕು ಹಾರಿಜಾಂಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲಿದೆ. ಇದನ್ನು ಪುಷ್ ಮಾಡಿದಾಗ, ಸೊ ಪುಷ್ ಅಂದರೆ ಹೆಂಗೆ ಬರುತ್ತೆ, ಸೊ ಪುಷ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ like this towards the block. Okay, this pushing is always towards the block. When you push anything, you have to just give the force towards the block. When you are pulling, what you do, away from the block. Okay, so this is the P when the force is pulling, this is the P when the force is pushing on the same block. Okay, ಸೊ ಇಲ್ಲಿ ಎರಡು ಕೇಸ್ ಬರ್ತವೆ. ಒಂದು ಕೇಸಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೊ ಈ ಬ್ಲಾಕನ್ನು ಪುಷ್ ಮಾಡುತ್ತೆ, ಪಿ ಅನ್ನೋ ಫೋರ್ಸ್ ಪುಷ್ ಮಾಡುತ್ತೆ, ಅದು 30 ಡಿಗ್ರಿ ಆ್ಯಂಗಲಿಂದ. ಆವಾಗ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಪಿ ಏನಿರುತ್ತೆ, ಓಕೆ 30 ಡಿಗ್ರಿ. ಇನ್ನೊಂದು ಕೇಸಲ್ಲಿ ಅದೇ ಪಿ ವ್ಯಾಲ್ಯೂನ ಪುಲ್ ಮಾಡುತ್ತೆ ಅದೇ 30 ಡಿಗ್ರಿ ಆ್ಯಂಗಲಲ್ಲಿ, ಆವಾಗ ಪಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು. ಅದಾದಮೇಲೆ ವಿ ಹ್ಯಾವ್ ಟು ಶೋ ದ್ಯಾಟ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಪುಷ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಪುಲ್ ಈಸ್, ಸೊ pull is less than P of push. We have to show that pull is less than push. Okay, so I'll take one by one. That is case 1. Okay, for the case 1, when the block is pushed by force P1 at an angle 30 degree. Okay, block is pushed by a force P1 at an angle 30 degree. I'll just note down the figure. So this may be the block, so this is the horizontal plane. So first one we taken as push. Okay, and I'll take an horizontal to the centroid. Okay, I'll let you know what is centroid. Centroid is a point where all the weight of the body is concentrated, so I'll take that as a center. Okay. Then this P1 will act this pushing, right? So pushing, take like this. So see the direction, pushing at a 30-degree angle. So due to this pushing, what happens? So weight is also given, that is 5 kilonewton, and due to this weight R is generated, and also if P is in this direction, the motion will be in this direction, right? The body will move in this direction. As this is pushing, we are pushing, the motion will be like this towards this. So the force, the frictional force will be opposite to that. If this is the P is like this, the force will be in opposite to that. Okay, because of this force P, the motion, the body will move in this motion. So body is moving like this, so friction will resist opposite to this. Okay, then what we do, we'll directly resolve the problem. So P is there, so P, okay, this force I'll just make it resolve in horizontal and vertical, and just I'll do resolve the force P. So P, this is the force P, so this is 30-degree. Okay, this is 30-degree, means this will be also 30-degree, alternate angles. So what it will be, P cos 30-degree, P sin 30-degree. Or else if you are taking this, you can also resolve like this. So this is 30-degree, right? So we know the component is like this and another component is like this. So this is P cos 30-degree or P sin 30-degree. So both are same. The horizontal value is P cos 30-degree, the vertical value is P sin 30-degree with the same direction. Okay, now I'll resolve it considering this. How will be the free body diagram? I'll show you here. So FPD, so this is the force R will be there, this is W force 5 kilonewton, and F force will be like this. F force, this P force will be like this. So this is P cos 30-degree, this is P, and here P sin 30-degree with also weight. Now I'll resolve it, that is summation of all the horizontal forces equal to 0, taking left to right as positive, and also summation of all the vertical forces equal to 0, taking upward as positive. So sigma h equal to 0, taking left to right as positive. What will happen? See here. So P, I'll take all the positive items. P cos 30-degree. Then what are the forces? This P and F is one forces. So minus F is equal to 0. So we know the value of P, we don't know. Cos 30-degree we know, that cos 30-degree, and here we also know that mu is given, that is 0.4. So mu is equal to F by R. Okay, so to make the problem easy for calculation, what I do is I'll take this, I'll substitute this for F, that is F is equal to mu into R. F is equal to mu into R. Okay, now I'll take vertical force is equal to 0, taking upward as positive. So take this equation number as 1. Now see here R is positive, so I'll take R. Next minus W, wait, and also we have another force, that is P sine 30 degree is equal to 0. So either you take F in terms of R or you take R in terms of F. Okay, we already taken F is equal to mu R, so I'll continue with that. So this may be the equation number 2. Okay, now I'll take this one again, I'll write, that is P cos 30 degree minus F, I'll replace with mu R is equal to 0. Let this be equation number 3. Okay, so now we know the value of mu, we know. Okay, cos 30 degree, how much? Cos 30 is 0.866, so P into 0.866 minus mu value they have given, that is 0.4 into R is equal to 0. What I do is P 0.866 P is equal to 0.4 into R, so R value is equal to 0.8666 divided by 0.4, that is 2.165 divided by P. Okay, or you can take, or I will do, what I do is, see, don't bring division during calculation. So 0.4 R is equal to 0.866 P, right? I want the value of R, so what I do, 0.866 divided by 0.4, it is 2.165 P. So our value of R is 2.165 P. Now I'll substitute this value of R in the equation number 2. So what is your equation number 2? That is R minus W minus P sine 30 degree is equal to 0. What we got? R is equal to 2.165 into P. So what we got? R is equal to 2.165 P. Okay, now R value 2.165 P minus this W is 5 kilonewton. Okay, the value of W is 5 kilonewton. We already taken it is as minus, so another time minus don't take. Then P sine 30 degree is equal to 0. What is happening? Now we have one value, one unknown is P. Okay, what I do is, so sine 30 is 0.5, so 0.5 P is equal to this 5 kilonewton, I will transfer to this side. Then I have 2.165 P minus this one, so these are both the like terms P, so 2.165 minus 0.5, it is 1.665 is equal to P is equal to 5, so which implies P is equal to 5 divided by 3.003 Newton. Just send this side, 5 divided by 1665, so P is equal to 3.003 Newton. Okay, understood? Just what I did, just I substituted the value of R in the equation number 2. Now we found the value of P. This value of P is when it is pushed value of P, pushing value of P. Now I'll take the case 2. What is the case 2? When block is pulled, block is pulled by force P at angle 30 degree. Okay, now I'll not write the free body diagram separately. Okay, we will imagine from now. Okay, so what I do, I'll write the free body diagram directly. So what was there? A force was block was there. It is driven by on the horizontal surface. Okay, so what was the weight? It is 5 kilonewton. Okay, so P pulling force, right, away from the block P, so at an angle of 30 degree. So due to this force, R force will be there, R. Okay, when it is pulled out, the motion of trend is like this. The block is moving in this direction, so the force, frictional force, will be F is equal to this one. So here we will first only take that mu is equal to 0.4. Therefore mu is equal to F by R. So F is equal to 0.4 into R. We will take F is equal to 0.4 into R. Now what we will do, we will resolve it. That is sigma h equal to 0, taking left to right as positive. Okay, we have one force P, and what we have to do, we have to resolve it in horizontal direction and vertical direction. That is, this will be P cos 30 degree, this is 30 degree. What is this? P sin 30 degree. Okay, if this is confusing, I'll write the free body diagram. How the free body diagram will be? So here I'll write the free body diagram. So I'll take the block. So this is P. Okay, so this is F. This is 5 kilonewton, that is W. So this is R. So this value will be P cos 30 degree, because this is inclined at 30 degree, and this value will be another P sin 30 degree. So here there are two forces, R and P. So horizontal force is equal to 0. What we'll get? I'll take here only 0.4 R. Okay, F is equal to 0.4 R, right? So F is negative sign, we have positive sign. First we'll take P cos 30 degree. Another force is minus this one, minus F, but I'll take as 0.4 R. 0.4 R is equal to 0. Okay, this will be the equation number 1. Okay, now what is happening? What we do is, I'll take this force as P2. We should not confuse. Okay, and the pushing force as P1. Just naming, that's it. Now this P2, so I'll take this P2 cos 30 degree. Now sigma vertical force is equal to 0, taking upward as positive. So other force upward ide, only vertical force you take. That is, first one is R plus P sin 30 degree, then minus 5 is equal to 0. 5 kilonewton is weight. Then what will happen? R plus P sin 30 is, sin 30 is, we know, that is half, 0.5. 0.5 into P is equal to 5. I'll transfer this 5 to that side. Then R is equal to 5 minus 0.5 P. So I'll take this P as P2. Okay, because it is in second case, no, so also I'll take this R as R2, because second case. there is no change in value, just it is second case, and this reaction is due to the force P2 to show that. So R2 is equal to what? 5 minus 0.5 into P2. Okay, now what I'll do, I'll just substitute this in this equation number 1. So let this be the equation number 2. So what is there? P2 cos 30 degree, I'll substitute 0.866. so this one, what I am doing, equation 2 in equation number 1. So minus 0.4. so what is the value of R2? 5 minus 0.5 into P2 is equal to 0. Now substitute 0.866p minus 0.4 into 5 is 2, minus into minus plus, so 2 into 0.5 is 1, so 1 into P2 is equal to 0, so this is also P2 only. Now this P2 and this P2, what will become? 1.866, this 2 I'll send it to that side, is equal to 2, therefore P2 is equal to 2 divided by 1.866, that is 1.07 Newton. So this is the force due to pulling. So in the question what they have given, we have to show that pull is less than push. So what we got? P2 value, P2 value is 1.07 Newton, which is less than P1 is, how much the P1 value? 3.003 Newton. So P2 is less than P1. Okay, hence the problem was solved. When it is pulled, the value of P is 1.07. When it is pushed, the value of P is 3.003 Newton. So this is how we solve this problem. Next we will go to the fourth problem. Fourth problem is somewhat this type only, but the force, the push and pull value at certain angle will be different. Okay, and the P value is given. I'll write down the question. So a body resting on a horizontal plane is required to pull off 100 Newton inclined at 30 degree. So a body resting on a horizontal plane, it will require a pull of 100 Newton at 30 degree to move that body, and it was found that push of 110 Newton inclined at 20 degree to the plane, so that the body to move. So determine the weight and also the coefficient of friction. Okay, in this question what they are telling is the body just to move. So this body just to move, it was pulled off, it was pulled off of 100 Newton, which is at 30 degree to just to move. And in the cases of pushing, it was required 110 Newton at 20 degree to move the body from that plane. Okay, here also we have two cases, when a pull of 100 Newton given at 30 degree and also a push of 110 Newton at 20 degree. So there are two cases. What we have to find? We have to find the weight of the body, what is the weight of the body, and we have to find the coefficient of friction. So to find the coefficient of friction, what we need? F and R. So we have to find F, R, W and P is given. Okay, P ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಈ ಪ್ರಾಬ್ಲಮ್ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ, ಒಂದು ಬಾಡಿ ಇದೆ. ಸೊ ಆ ಬಾಡಿ ಹಾರಿಜಾಂಟಲ್ ಪ್ಲೇನ್ ಮೇಲೆ ರೆಸ್ಟ್ ಆಗಿದೆ. ಸೊ ಆ ಬಾಡಿನ ಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ 100 ನ್ಯೂಟನ್ ಪುಲ್ ಫೋರ್ಸ್ನ ಎಳ್ಕೊಳೋ ಫೋರ್ಸ್ 100 ನ್ಯೂಟನ್ ಆಫ್ ಅಟ್ 30 ಡಿಗ್ರಿ. ಓಕೆ, 100 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ನ ಅಟ್ 30 ಡಿಗ್ರಿ ಎಳೆದ್ರೆ ಆ ಬಾಡಿ ಮೂವ್ ಆಗುತ್ತೆ. ಅದೇ ಬಾಡಿನ ಪುಷ್ ಮಾಡಬೇಕು. ಎಷ್ಟು? 110 ನ್ಯೂಟನ್ ಫೋರ್ಸಿಂದ ಪುಷ್ ಮಾಡಿದರೆ ಅಟ್ 20 ಡಿಗ್ರಿ ದಟ್ ಬಾಡಿ ವಿಲ್ ಮೂವ್. ಓಕೆ, ಹಾಗಾದರೆ ಆ ಬಾಡಿ ವೇಟ್ ಎಷ್ಟು, ಆ ಸರ್ಫೇಸ್ದು ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಐ ವಿಲ್ ರೈಟ್ ದ ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ಬೋತ್. So see here, so this may be the body and this is the horizontal surface. Okay, now this is centroid. So a pull of 100 Newton. So pull of 100 Newton at 30 degree, correct? So we have to find what we have to find. We have to find weight S2, we have to find the reaction R. Okay, for this case we will take R1. What is R1? And also what is F? And after we get that, we have to find mu. Here in the same case, same body is there, horizontal force. Okay, it is pushed, okay, by 20 degree angle by a force of 110 Newton. Force is different, okay, 110 Newton force, 20 degree, so that the body will move. Okay, so we have to find the weight. So we have to find the R value. So I will take this as R2. W will be same body. So what is this? F. Okay, what is this F? We have to find, and also we have to find mu will be same. So here what is the mu value? So what it becomes? F is equal to mu R1. Here F is equal to mu R2. Okay, so what is the F and what is the value of R1 and R2 and what is the weight of the body? We'll see in the next page. So we have two cases, right? So now we will take both the cases. Okay, so what is the FBD here? This is the case for pulling, right? So the pulling force was about 100 Newton at 30 degree, right? So I'll take this. Okay, now pulling force, so this is P at 30 degree. Okay, so the weight of the block, weight is we have to find. So F will be like this, then R will be for this. Okay, we saw in the previous page, no? Okay, now this P they have given as what? 100. Okay, this P they given as 100. So now here in the second case, pushing force. So the pushing force, how much is the force? 110 at 20 degree. Okay, at 20 degree. So same R will be there. So here we'll take this as R1, here we'll take this as R2, or let it be you take as R because it is the same body. Okay, the force are different at different angles so that it could be moved, and this be the W. So weight of this block is same. Okay, then what are the force? Then also the friction force will act in like this. So friction force will be like this. Here this is F and this will be F. We have to find what? We have to find mu and W we have to find. So now what we'll do means we'll just apply the sigma horizontal equal to 0, taking left to right as positive at both the condition. Okay, what we will get? So see, so that is P. So we'll resolve them. So the horizontal quantity is P cos 30 degree and the vertical component is P sin 30 degree. However, here what will happen? So and pushing force is like this. So see the direction. So one will be the vertical force and one will be the horizontal force. So the horizontal force will be P cos 20 degree, vertical will be P sin 20 degree. Okay, the resolution force you know already. So now, so the horizontal force is P cos 30 degree. Okay, then again is minus F is equal to 0. Here what is happen? Here P is different, here is P is different. Okay, so what is the horizontal components? P here left to right. Okay, left to right it's positive, what we have assumed that P cos 20 degree. Okay, and this F is in this direction, so minus F is equal to 0. So now what happens? We get the F value here. So P cos 30 degrees, the value of P is 100. So 100 cos 30 degree, 100 cos 30 degrees, so 86.60 minus F equal to 0. Here 110, this P is 110, so 110 cos 20 degree, that is 103.36 minus F is equal to 0. So here the value of F will become 86.60 Newton. Here it will become 103.36 Newton, right? So we got the value of F. Now we will take sigma vertical force equal to 0, taking upward as positive. So vertical forces here, so R is the vertical forces, right? Then P, and that is also upward here, upward force, so P sin 30 degree, then this minus W is equal to 0. Okay, then what we can do, this R we don't know, P is 100, so 100 sin 30, it is 50 minus W is equal to 0. Okay, summation of V is equal to 0, taking upward as positive. Now what will happen? See here, this same R will be positive. Okay, then this is going downwards. See here, this is going downwards, right? So downward what we take? Negative, because upward is always positive. So P sin 20 degree minus W is equal to 0. Okay, now R minus what is P sin 20 degree, that is this P is 110 degree, don't forget it, values are same, no different. P sin 120 degrees, 37.62 minus W is equal to 0. Now here we have two equations, so let this equation number 1 and let this be equation number 2. Okay, from these equations what we do is we just take what is R is equal to, R is equal to, what will happen, this W will go, it will become positive, minus 50, R is equal to W minus 50. Here what happens, R is equal to, so W will go that side, W plus 37.62, correct? So now here the body is same and the horizontal plane is same, and what we need to find, we need to find mu is equal to this, the friction coefficient. So when the body is same and the horizontal plane is same, this mu will be same. Okay, now what I do is mu for push is equal to mu for pull. As the body and the horizontal surface are same, I can assume this is assumption from the given question. Okay, so what is this value? F by r. This value is F by r. So what I getting from F, from the push value, I'll equate with the pull value. So what is the F I got here? 86.60 divided by r. What is the value of r? W minus 50. So here what I got? F 103.36 divided by W plus 37.62. Now I'll cross multiply. So 86.60 into W plus 86 into 86.60 into 37.62, it will be 3257.892, which is equal to this one 103.36 W minus now 103.36 into 50, that is 51.68, 5168. Okay, now we have only one unknown, that is W. Okay, take W at one side, that is I'll take this or I'll take this one. What I do is, because this is bigger one, I'll send this to this side. So when I send this to this side, it will become negative 103.36 minus 86.60, that is 16.76. okay, so I'll make this to come this side. What will happen? 3257.892 plus 5168, it is 8425, 8425.89. okay, this is W. So what will be the weight? So this divided by 16.76, 502, 502.73 Newton is the weight for this question. For the block, the weight is this one. Now it's easy to find what mu is equal to F by R. Take any one, that is F, you take this 86.60 divided by W. How much is W? 502.73. I am taking this one. Okay, minus 50. So 86.60, 50 minus 50, 452.73. So your mu value will be 86.60 divided by, answer will be 0.19. So value of mu is 0.19. So this type of problems will come, so that when the body is given and on that body two forces will act, so we can consider this concept, that is mu is equal to F by R, and we can solve the problem. So we'll come to the last problem of this topic. Okay, that is, I'll write the question and I'll let you know. Next problem is, if a block weighing 2000 Newton, this is the block, this is weighing 2000 Newton, is attached to one end of the cord, okay, which passes around a frictionless pulley as shown, carries a load of 800 Newton at each end. Okay, find the value of P. Okay, take mu is equal to 0.35. Here they have given two cases. If motion is impending towards left, if due to this force, if due to this force this body moves toward this side, okay, in the force of P, what is the value of P? If this body, if this block, okay, if it moves towards its right, towards the load, what will be the force of P? Okay, we have to find the value of P. ಏನದು ನಾವು ಪಿ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಬೇಕು ಯಾವಾಗ ದಿಸ್ ಬಾಡಿ ಇದೇನು ಬಾಡಿ ಇದೆಯಲ್ಲ ಇದು ಈ ಕಡೆ ಮೂವ್ ಆದಾಗ ಮೀನ್ಸ್ ಟುವರ್ಡ್ಸ್ ದ ಲೆಫ್ಟ್ ಪಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು, ಇದೇನಾದರೂ ಈ ಕಡೆ ಮೂವ್ ಆತಂದರೆ ಪಿ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅದೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಫ್ ಮೋಷನ್ ಈಸ್ ಇಂಪೆಂಡಿಂಗ್ ಟುವರ್ಡ್ಸ್ ಲೆಫ್ಟ್ ವಾಟ್ ಈಸ್ ದ ಪಿ ವ್ಯಾಲ್ಯೂ, ಇಫ್ ಮೋಷನ್ ಈಸ್ ಇಂಪೆಂಡಿಂಗ್ ಟು ದ ರೈಟ್ ವಾಟ್ ಈಸ್ ದ ಪಿ ವ್ಯಾಲ್ಯೂ. ನಾವು ವಿತೌಟ್ ವೇಸ್ಟಿಂಗ್ ಟೈಮ್ ವಿಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಗೋ ಟು ದ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಫಸ್ಟ್ ಏನು ಮಾಡೋಣ ಸೊಲ್ಯೂಷನಲ್ಲಿ. ಸೊ ಐಲ್ ಟೇಕ್ ದ ಸೊಲ್ಯೂಷನ್. ಸೊ okay, here what we do is I'll take the free body diagram of this. Okay, I'll take the free body diagram. So how I'll take, so this is the free body diagram. Okay, already started. I'll take this as a solution only. So what is this? This is 800 Newton, 800 Newton, and again we have what, we have one value T. So the free body diagram of this load. Okay, now what we will get, so T is the tension, right? T is the tension. Okay, just apply that sigma V is equal to 0 taking upward as positive. Why? Sigma H force is not there, only we can see the vertical force, that is T minus 800 is equal to 0. So the value of T will be, we'll get directly, that is 800 Newton. So we got the value of T, that is 800 Newton. Now we'll apply the case if motion is impending towards right and motion is impending towards left. So I'll take the first case that the motion is impending towards the left. Motion towards left. Okay, I'll take the free body diagram of that block. Okay, this is the block. So weight of the block is 2000 Newton, 2000 Newton. Okay, so due to that weight what we will get, we'll get a reaction. I'll take as R1. Then another force T was there. So as it, what the value of T we got, 800 Newton, and the pulley is frictionless, so there is no loss in the energy. We'll directly get this 800 Newton. So see here T, so this T we got as 800 Newton, so frictionless pulley, so there is no loss in energy, so T value will be 800 Newton. Okay, now T will be 800. Okay, and what we, the motion is towards the left, motion is like this. Okay, if the motion is like this and the value of P we have to find, what is the value of P. Okay, this block is moving towards the left, then the frictional force will be towards the right. This is F. Okay, so this F is what, okay, let's take this. So now F is equal to, I can write as mu into R. So mu is equal to F by R, so F is equal to mu into R. So we got the mu value as given 0.35. Okay, so I'll take R1. So F is equal to, I'll directly take 0.35 R1. So 0.35 R1. Now I'll resolve the forces one by one. First I'll take vertical forces, sigma vertical taking upward as positive. So what are the vertical forces now? Here weight 2000 Newton. So I'll take first R1, positive one, R1. Okay, so when we go to the next problem, we'll just imagine, so this T, so this will be at 30 degree, right? This T vertical component will be T sine 30, horizontal component will be T cos 30. So you make up in mind to take the horizontal component and vertical component when the inclined force is given. So R1 is there, so I am taking directly here R1 plus T value is 800, right? 800, what I am taking vertical, so sine 30 degree, then minus 2000 is equal to 0, correct? Now I can get the value of R1, that is 800 sine 30 degree, 800 sine 30 degree. So 2000 I will send that side. So 2000 minus 800 sine 30 degree is 1600. So the value of R1 is 1600 Newton. Let I will take this equation number 1. Now horizontal force is equal to 0, taking left to right as positive. Now what are the horizontal forces? I will take first P1, T, but which are positive, 800 cos 30 degree, then your P is there, minus P, then which are the forces are there, then this F is also positive, that is 0.35. we got the value of R1, right? I'll directly substitute it, is equal to 0. So I can get the value of P on substitution. I'll tell you the value. So 800 cos 30, that is 692. So the value of this is 692.82. Now 0.35 into 1600 is 560. So what I do is, upon substitution, this value is 560. I'll just add them. 560 plus 692.82, it is 1252.82. 1252.82. so the negative sign cancels, so you calculate this, you will get 1252.82 Newton as the value of P. So R1 is 1600, P is 1252.82. so what we need to find? P. We got the value of P. Now case 2, when the motion is impending, right, motion is impending right. So now I'll take the same diagram, but the motion is like this. So here the motion will be towards the right, the force P will be like this, so R will be like this. So for this I will take R2, okay. So the weight will be 2000, then the T force will be 800, and this will be 30 degree. Now friction force, where you have to take, it is impending this side, we have to take the friction as this side. So this, here also F is equal to what? 0.35 R2, okay. Same, what I do, summation of vertical force is equal to 0, okay. When I do summation of vertical force is equal to 0, what I get, this R2 plus, so 800 sine 30 degree, then which are the force, minus 2000 is equal to 0. So value of R2 will be same 1600 Newton. I'll take this as equation number 3. Now summation of horizontal force equal to 0, taking left to right as positive, okay. Then what are the forces left to right? There is only one force, 800, which comes positive, cos 30 degree minus P minus F is equal to 0, right? Now 800 cos 30 degree will be 800 cos 30 will be 692. 692.8 minus P minus this is 0.35 into 1600 Newton is equal to 0. Then the force P will be, tell me what, I'll calculate now. It will be 132.82 Newton. So after calculation we will get P is equal to 132.82 Newton. Here see the difference, we got negative sign here, negative sign here, here we got negative positive sign, negative sign. So that is the difference, main difference, which will make the value of P less. Because of the value of P is less, it is going towards the left where there is the force of 800 Newton. It is 800 Newton force is dragging the force of 132.8 Newton. So it is going left, right. Okay. Here when you see the force of P is greater than the force of T. So it is going towards the left and it is dragging the 800 Newton force towards the P. So these are the type of problems which will be asked in the examination in this topic. The topic which is the problems on horizontal plane. So the problems are complete. So in the next class we will solve the problems on block placed on inclined plane. Okay, so as this was the first topic, I went slowly, but in the coming topic I'll go speed. Thank you.